Hello guys, now we are going to continue with S block elements and now we are going to discuss their chemical reactivity. Alkali and alkaline earth metals both have low ionization potential. If we compare both, then the alkali metals have lower ionization potential than alkaline earth metals. Therefore, alkali metals are more reactive than alkaline earth metal. But if we consider these elements with respect to P, D and F block elements, then these two group elements are highly reactive, highly electropositive, and they almost react with every element. So, some of the important reactions we have to discuss here. So, we are going to discuss now reactions of S block element. So, the first reaction is reaction with oxygen. Both these metals, alkali metals as well as alkaline earth metals, are highly reactive. So, they react with oxygen forming corresponding oxide. So, when I am talking about alkali metals, react with oxygen gives you metal oxide. This is alkali metal. Now, this reaction actually is shown by lithium in alkali metals. The other elements are not actually forming normal oxide. So, lithium and sodium generally form normal oxides, but sodium also form peroxide. So, sodium when they react with oxygen gives you sodium peroxide. While rest of the elements like potassium when they react with oxygen giving you potassium superoxide. So, in alkali metals only lithium forms normal oxide while the other elements can form normal oxide, but they are generally form peroxides and superoxide. When I am talking about alkaline earth metals, they are forming metal oxide like this way. So, here beryllium, magnesium and calcium form beryllium, magnesium and calcium forms normal oxide, while barium, strontium form superoxide also. Barium when react with oxygen gives you barium peroxide. Barium peroxide. So, barium, strontium also form barium peroxide. So, this is the reaction, these are the reactions with oxygen. They are highly reactive. Order of reactivity goes on increasing as we move down the group in both the cases. So, here I can write in both groups order of reactivity increases as moving down the group. Okay. So, this is the reactivity with oxygen. Now, I will go for the next one. That is reaction with hydrogen. Since all these metals are highly reactive, they react with hydrogen forming metal hydride, where these metal hydrides are ionic in nature. So, when I am talking about alkali metals, when it reacts with hydrogen under various conditions, we are getting this metal hydride. And these metal hydrides are ionic in nature. So when I am talking about ionic in nature, they easily soluble in water, react with water, giving you metal hydroxide and liberates hydrogen gas. Okay. Now, in that order of reactivity here, order of stability we can say, order of stability of metal hydride, alkali metal hydride decreases down the group. Now, what is the reason behind it? The reason behind it, as we move down the group, size of the atom goes on increasing, and therefore there will be low lattice energy. So that breaks crystal very easily. So because of the low lattice energy, the metal hydrides are unstable as we moving down the group. Similarly, alkaline metal hydride, same way, but they are forming MH2, that is alkaline metal hydride. In that, BeH2 is a covalent solid and it has a polymeric structure, while the rest of the hydride MgH2, CH2, etc. are ionic. And the same way, as we move down the group, the order of stability goes on decreasing. The reason is same. Now, the next reaction which we are going to discuss now, that is reaction with water. Being low ionization potential, high electropositivity and negative standard reduction potential. So, low ionization potential, high electropositivity and negative SRP value, standard reduction potential values. They react with water, liberating hydrogen gas. Order of reactivity goes on increasing as we move down the group. Especially in alkali metals, all the alkali metals react with water violently. And we are getting metal hydroxide and the hydrogen gas is liberated. Beryllium is not reacting with water, even not with the steam, but magnesium onwards all react with water. Magnesium actually react with hot boiling water, calcium react with normal water, and so on. The order of reactivity increases. So, beryllium unreactive, okay, towards water, even in a solid, liquid and steam. Okay. Magnesium, calcium, strontium, barium all react with water, giving you metal hydroxide MOH twice and M-OH twice and hydrogen gas is liberated. The reason behind it, they have negative standard reduction potential. Now, when we are comparing alkali metals and alkaline earth metals are more reactive than that of the alkaline earth metal. Some of the alkali metals are reacting violently, exothermic, producing exothermic reaction. Okay, and because of that, all these metals are actually kept under kerosene or under petroleum oil, so that they should not react with moisture. So the next reaction which we are going to discuss, that is reaction with nitrogen. Alkali metals do not react with nitrogen, no reaction, except lithium. Lithium react with nitrogen, giving you lithium nitride. Okay, lithium nitride. While other alkali metals react with alkaline earth metals, react with nitrogen, giving you corresponding metal nitride. This way. This is alkali metal nitride. This is lithium nitride. Now these nitrides are highly reactive. When they react with water, liberates ammonia. So this is mainly distinguishing reaction between alkali metals and alkaline earth metals. That alkali metals do not form nitrides when they react with nitrogen. Therefore, we can say this way, whenever alkali metals kept open, exposed in air, it actually reacts with oxygen, moisture and carbon dioxide. So oxygen gives you metal oxide, then metal hydroxide and metal carbonate. Well, alkaline earth metals, when exposed in air, they actually form metal hydroxide, metal carbonates and metal nitride also. Okay, so these are some of the reactions. Few more reactions we have to discuss for alkali and alkaline earth metals, that we'll discuss in the next session. Thank you.